This is thermal conductivity of insulating powder apparatus. So in this experiment we are going to determine the thermal conductivity of insulating powder. So first, what is meant by thermal conductivity is it is one of the important properties of the material and its knowledge is required for analyzing the heat conduction problems. So physical meaning of thermal conductivity is how quickly heat passes through a given material. So thus the determination of this property has one of the considerable engineering significance. So there are various methods of determination of thermal conductivity for suitable different materials. The present apparatus is suitable for finding out thermal conductivity of materials in powdered form. So in this pair we are having a powdered material. So and we are going to determine the thermal conductivity of this equipment. So diameter of this sphere, inner diameter is 100 mm, outer diameter of this sphere is 200 mm. Mica heater we are having, it is a nichrome wire, 140 mm dia, 2 numbers is provided. One type dimmer start, so that is 2 amps, 230 volts AC current which is wire wound. Insulating powder material we are having asbestos inside this sphere which is 6.5 kilograms approximately. Digital thermometer, temperature indicator is provided, digital voltmeter is provided here and digital ammeter is provided here. So next, this experiment, in this apparatus it is mounted in a table. So it consists of two thin walled concentric copper spheres. So you are having this visible sphere is one and inner side you are having a one more copper sphere. So the inner sphere houses the heating coil. The heating coil is nichrome wire, so which is wound on a mica sheet. The insulating powder is packed between the two shells. So this is outer sphere, inner sphere is there. In between inner and outer sphere we are providing an insulating powder which is asbestos. So power supply to the heater is given. So this is power supply, you have to switch on this and you have to adjust this heater input. So get the values in the voltmeter and ammeter. So initially you can fix this at 100 volts. So you can measure the ampere value, so that is current value, and you have to note the temperatures T1 to T12. So 1 to 6 which is for inner sphere and 7 to 12 which is for outer sphere. So 4 thermocouples are embedded on the inner sphere and 6 thermocouples are embedded on the outer sphere. All 10 temperatures are measured on a temperature indicator by operating this selector switch. So these readings enable to find the thermal conductivity of the insulating powder. So first you have to switch on this switch. So then you have to apply the power here. So you have to wait for 1 hour for getting the steady state conditions. So at that time only the insulating powder will get heated. So then you have to note down the readings in the observation tables from temperature T1 to T10. So you have to repeat this experiment for different heat input. So now I am giving 100 volt means you have to adjust this and you can take it to 120 volts. So and you have to wait for another 10 to 15 minutes and you have to take the values from T1 to T10. So after the experiment is over, you have to switch on this main switch. So this is the tabular column. So you can measure voltmeter value here, you can write the ammeter value here. Inner sphere temperatures from T1 to T4, then outer sphere temperatures from T5 to T10 you have to take it here. So this is for 100 ohms, 100 volts. So next you can increase to 120, 140. Likewise you can increase the voltage value and you have to wait for 10 to 15 minutes. So after that only you have to write the readings because you have to attain the steady state conditions. So first one for making out the calculations, average temperature of inner sphere. So you are having 4 T1 and the T4. So you have to T1 plus T2 plus T3 plus T4 divided by 4. So you can get the average temperature of the inner sphere. So next average temperature of outer sphere. So that is T5 to T10 divided by 6. You can get the average temperature of outer sphere. So next is a heat input value, so which can be measured by Q equal to V into I into 0.86 for getting it in a unit of kilocalories per hour. So from this, after that you have to find the thermal conductivity and its formula is K equal to Q into R0 minus Ri divided by 4 pi R0 minus Ri into T in minus T out. So T in is the average temperature of inner sphere, T out is the average temperature of the outer sphere.